All right, let's use the Pythagorean theorem to solve for any side in a right triangle. In my last video, we used the Pythagorean theorem to solve for C in a right triangle, where we have to remember that C has to be the longest side. It has a fancy name. It's called the hypotenuse. And when you are looking at a right triangle, you can always find C by drawing an arrow from the corner of your box that represents that this is a right triangle or a right angle. And that arrow will always point to C. The other two sides, as we mentioned, can be A or B. It really doesn't matter which side is which. They're interchangeable. C must be the longest side. So in the last video, all of our triangles ended up where C was the missing side. So just kind of a quick reminder, let's go ahead and have one more of those to get you back into the Pythagorean theorem. So if you have a right triangle and you have a missing side length, and you want to find that missing side length, the Pythagorean theorem lets you do that really easily. So first of all, you have to identify which side is C. And again, it's always the side that's across from the right angle. The Pythagorean theorem says that if you take a squared and add b squared, it will be equal to c squared. So c is our missing length. We're going to leave this as c squared. And a and b, again, it doesn't really matter. I'm going to put in 4 for a, and then I have to square it. I'm going to put in 3 for b. And because the formula says I have to square it, I'm going to. 4 squared, remember, is not 8, it's 16. And 3 squared is not 6, it's 9. And when we add 16 and 9, we get 25, which hopefully you can see is a nice result. We're not done, because what we have found is what c squared is. Remember, if we put that square on this side, the area of that square would be 25. But what we want to know is how long is the side of the square. And so we would need to figure out what number times itself gives us 25. And the mathematical tool for that is to take the square root. The square root tells you what number times itself gives you that value. And in this case, the square root of 25 is 5, because 5 times 5 is 25. Over here, you have to do the same thing to both sides, and our square and square root cancel each other out. They're opposite operations. And so that gives us C. So just double checking, if C is 5, is it the longest side in our right triangle? The answer is definitely yes, which means that our answer is reasonable and, as always, hopefully accurate. All right, let's see what happens when we have a triangle where C is not the missing side length. We still have a right triangle. We have a missing side. That's your big hint that you can use the Pythagorean theorem to help you find that missing side. So we need to identify which side is C, and you can use that corner of your right angle to point to C. So we now know that 30 is our C. So if we have our formula a squared plus b squared equals c squared, we are going to put 30 in for C. 24 can represent either A or B. It doesn't matter. I'm going to have it be A, because if I substitute a value in for B, it ends up not looking like a 6 as I'm working with this. So be careful anytime you have a lowercase b. It could end up looking like a 6, and then you end up making a mistake just because of a handwriting error. So I'm going to call my missing side length A, just because even though A can look like a 9 if you're not careful, it doesn't get as confused if you write your A without a really straight tail. So let's go ahead and add in our value for B, which is 24, and we need to square that. So now you can see it's a little bit different. We aren't going to just square and add and get our answer. We have an equation that we will have to solve. And before you can solve the equation, you do need to simplify. So let's go ahead and simplify by squaring our values that we have in for B and C. A is still just going to stay A. So we have A squared. 24 squared is 576. You can use a calculator to find that out. You can do it by hand. Either way. 30 squared is one I wouldn't think you should use a calculator for, only because 3 squared gives you 9, and then you have 2 zeros after it, so 900. Kind of a nice one. All right, so now we have an equation that we need to solve for. And remember, you want to keep track of your equal sign. And you want to make sure that we're moving things away from our variable. And you work backwards through the order of operations as you're solving, because we work backwards to solve equations. So we are not going to worry about this square first. We're going to take care of the addition first. We don't want a squared to be added with 576, so we're going to take that away. We're going to subtract 576. And what you do to one side, you must do to the other. Just keeping it nice and balanced. And what we have left over here is just a squared, which is what we want. We want to start to get a by itself. We just got rid of the 576. And when we subtract over here, we're left with 324. So now this is one that's a little bit more than maybe what you have memorized yet. If you've already memorized all of your perfect squares to 20, that's awesome. That is a goal that you should have as an 8th grader. If you were taking the state test, that is an expectation. They won't give you a calculator necessarily for those. So if you haven't yet memorized them, you can go ahead and use your calculator to help you out. But there is a number that when you multiply it by itself, there's an integer, I should say, that when you multiply it by itself, you get 324. And that integer is 18. So to undo this square, we take the square root. We're going to do that to both sides. This gives us just a, which is what we want. And over here, we get 18. So it's always a good idea to double check that your answer makes sense in your triangle. So we need to make sure that 30 is our largest value because it's side length C, and C must be the longest side. And if we have A as 18, B as 24, 30 would be the longest side. So our answer is reasonable. It makes sense. So we can know that at least our answer is reasonable and, as always, hopefully accurate. All right, let's do one more just to make sure you've got it. Again, we're looking for the missing side length and a right triangle. That is our clue that the Pythagorean theorem will help us out with that. So the Pythagorean theorem says that a squared plus b squared should equal c squared every time. We have to watch out for which side is c. So take the corner of your right angle marker and draw an arrow, and it points to c. So we can tell now that 15 is our value for C. And these are not variables, these are meter labels. So this is 5 meters, 15 meters. So you don't need to include the label when you're calculating the values for the side lengths. All right, so let's go ahead and put in 15 for C, which means we're going to need 15 squared. And then 5 can be either A or B. Let's go ahead and use B, even though we do need to be careful that we don't think that it's a 6 as we're working through our equation. So I'm going to go ahead and put in 5 for my A, which means I need to square that. B is going to remain B until we figure out what it has to equal for the formula to be true. So we have an equation to solve. We want B alone. It's definitely not alone yet. Make sure you keep track of your equal sign. You want to keep everything balanced. What you do to one side, you must do to the other. So let's first go ahead and simplify before we start to solve. 5 to the second power, remember, is not 10. It's 5 times 5, which gives you 25. The b squared we have to leave. There's nothing we can do with that yet. And 15 squared is 225. Another one of those that you want to get memorized. For some reason, that was an easy one for me to memorize, and I don't know why. Some of the other ones are harder, like 17 squared, for some reason, doesn't stick as well. But anyways, work on that. You want to get through 20 to the second power, or 20 squared if you can. All right, back to this. We want b alone. It's not alone. It's being squared. It's being added with 25. We're ready to solve. It's been simplified as far as possible. And when you solve, you work backwards to undo things. So we need to work backwards through the order of operations, which means we need to get rid of what is being added with b squared. And if I take 25 off of this side so that b squared is closer to being alone, I have to take 25 off this side. It's a positive 25, so I'm going to subtract 25. 25 minus 25 gives us 0. So 0 plus b squared is just b squared. 225 minus 25, that's a nice simple subtraction to do in your head. We get 200. And now what this is saying is if we were to build a square off of this side, it would have an area of 200. And 200 is not a perfect square. The square root of 200 is not 100. Sometimes students will just divide it by 2 and think that's good. But if you multiply 100 by 100, you do not get 200. 100 times 100 is 10,000. Vastly different, so be careful. So when we are trying to find that number, when multiplied by itself, we get 200. You can use your perfect squares to help you out with that, to estimate, or you can just use a calculator. If you wanted to practice your estimation, you could possibly recognize that 15 squared was pretty close to 200, but it's bigger. And that would mean that 14 squared would have to be the one below it. And you might already know that 14 squared is 196. So we can see that the square root of 200 is going to be pretty close to 14. Maybe 14.1, maybe 14.2, but certainly not 14.8 or 9. It's not closer to this than it is to this. It's only 4 numbers away from here. Here it's a full 25. So probably 14.1, 14.2. You can use your calculator to get a more precise estimate than that. Remember, the square and the square root cancel each other out. That's why we're doing that. And you must do the same thing to both sides. So over here, we get b. And when you type in the square root of 200 into your calculator, you get 14.14 plus a bunch of other numbers after it. But if we're rounding to the nearest tenth, you just look at the number that's in the nearest hundredth place. So we get 14.142 and a bunch of other numbers. Rounding to the nearest tenth, if this number is 5 or more, this would increase to a 2. If it's between 0 and 4, this stays the same. So our answer that we're going to use here, because I want you to round to the nearest tenth, would be 14.1. So then just double check that it makes sense with your original problem. And we want to make sure that 15 is still our biggest number. It definitely is. So now we can see that the side length B is 14.1 meters. And that's a reasonable answer given our right triangle values we already have.